Welcome back. Let's do a ring gear set. Now these instructions are posted and I'm going to pull these off to my secret monitor and follow them, but you might want to refer to them as well. I'm going to use, to explain this thing, this diagram right here. So what we've got is a ring gear set. It's a 6-to-1 ratio. That is, the center gear is driven, and for every turn of the center gear, the outside gear turns 1/6. So there's different ratios between the different gear meshings, but the overall effect is 1:6, as shown by the math up at the top. So let's kind of go through some of these teeth ratios here. So I have a 72 tooth gear. I have a 36 tooth gear, an 18 tooth gear, and a 24 tooth gear. The 24 meshes with the 36, so that's this division up in here. The 36 and the 18 are on the same shaft, so they turn together. Then the 18 tooth meshes with the 72 tooth ring gear. So this is the calculation up here, and with the you can do this calculation with number of teeth, and you get 6. You could also do it with the pitch diameters, and the pitch diameters are given. The ring gear has an 8-inch pitch diameter. This one here is 2.4. Then you've got a 2-inch pitch diameter and a 3.6 pitch diameter. So coming up with these numbers and these pitch diameters is kind of beyond the scope of this course. There are higher level courses where you'll do this kind of calculations, but here we just want to learn the basics of gears, and mainly we want to get practice on how to draw this thing in AutoCAD. But yeah, that's the math that I've done for you already. The other thing that I've chosen is the pressure angle, which is somewhat arbitrary. I chose that to get the teeth looking nicely. Like if you fiddle with this pressure angle, the teeth will, some of them will get fatter, some of them will get longer, and it'll just change the overall look of the teeth. So I designed this thing, I drew it several times with several different pressure angles, and 25 turned out to be the nicest one. Okay, so this is similar to the previous lab, except we have different size gears. So we need to draw the involute teeth separately for each one of these gears. Okay, and then the other tricky part is what's going on down here with the ring gear meshing with the 18 tooth gear. This little mesh going on right in here. That's a little bit tricky, so we got to talk about that. So I've sort of blown that up over in here. All right, and what you can see is I've drawn one of the teeth on the little gear. I've drawn it several different times in different rotations, sort of simulating what it does when it dives into the ring gear and then kind of dives out. So I'll go through the process in CAD, but basically what's happening, let me draw on here. What's happening is this gear is turning this way about this center, and while that's happening, the little gear is turning this way about these 5 centers, okay, because these center points are going to be moving, and the ratio is 4-to-1. So if I move this by 1 degree this way, then I need to move these ones by 4 degrees. It's hard to write with a mouse on here. Okay, I'll do this in CAD and you'll see what I mean. Okay, so I've got AutoCAD open here, and I've just drawn an 8-inch circle, and let's just check, is that 8 inches? Yep, radius 4, diameter 8 in the properties window. So our 8 inches is the pitch diameter of the ring gear. So I need to draw a couple of circles. So I'm going to draw a circle, and I'm using center snap here. So make sure in your snaps that you have center snap turned on. So I'm drawing a circle at the center of this 8-inch circle. I want a D for diameter, 2.4 inch pitch diameter. Then I want another circle that's at the center, and it's going to have a 2-inch diameter. Then I want another circle at the center, and it's going to have a diameter of 3.7. 3.6, sorry, 3.6. Then I got to move a couple of these guys. So quadrant snap is handy here. There's 4 quadrants on a circle. Okay, top, bottom, left, right. That's a nice little snap. So I'm going to take this guy and that guy, this guy, and the little guy need to be moved. I'll use the M for move, and then snap to, let's see, the this bottom quadrant here, and drag that down to the bottom quadrant there. That's what I want. Okay, so see how everything intersects there. Double check your work, make sure everything is the right diameters as you go along. All right, what's next? Okay, we need to draw a whole bunch of involute curves. So I'm gonna, oh no, first we need to draw the pressure angles. Okay, so quadrant snap is fighting me. I'm going to turn it off. All right, so we want to draw a line from the center of this guy to the center of that guy. Then we want to draw the 25-degree pressure angle, which starts here and goes off some arbitrary distance at 25 degrees. And likewise, I got another one down here at some arbitrary distance and 25 degrees. Then lengthen them. Okay. Lengthen them. Then draw the perpendiculars. Make sure you have endpoint snap and perpendicular snap on in your snaps. And draw a line from the end point of this to perpendicular to that, and another one from the end point of this to perpendicular to that. Then we can fillet radius 0. We can trim up these corners at least. Okay, fillet radius 0. That one was fighting me a little bit. Then let's see, we could, I could get it drawn with just what I have here, but let me make it look like the instructions so that it's just to be consistent with the instructions. We can drag that guy up to there. We can drag this guy to there. Let's shorten this guy. Let's mirror these things just so that it looks like the instructions. It's a little bit TMI, but that's fine. Okay, I think, yeah, that's what it looks like. Now, what we've got is the pitch circles, right? So construct all of these lines of contact, these 25-degree lines of contacts through the intersections of the pitch diameters, the pitch circles, right? Then we can draw the base circles that the string winds on, right? There's the base circle that the string winds on for there, and here's the base circle that the string winds on for that dude, and here's the base circle for this guy. Okay, now the teeth can only be as long as the addendum circle, right? Because the addendum circle intersects with the base circle of the meshing gear. This guy, that addendum circle, it's really specifying the maximum length of the teeth, right? And we can draw another addendum circle right here. Okay, so this is the maximum length of the teeth, and the teeth start from this base and go up a maximum of this. Likewise, the teeth down here start at this base and go up to a maximum of this. And here on the little bitty gear, the 18-tooth gear, the teeth start at that base, and they're going to go up until they point. So that one's a little bit different, so we don't need an addendum circle. You're just going to make the teeth pointy on that because they're going to hit with a mesh gear. So I'm sorry, they're going to mesh with the ring gear, which is a little bit different. Okay, now it's everybody's favorite. You need to get out your Excel spreadsheet and start drawing a bunch of lines and stuff. So let's start off. I need quadrant snap back on again. Let's start off with these strings. Remember, come off the base circle because we're winding a string around the base circle. And I'm going to use, in fact, these other snaps are kind of, you can turn off, you can F3 turn off these object snaps when they start fighting you. It looks to me like a 1-inch string will be just barely long enough. So I'm going to go with that. 1 inch at 90 degrees. Okay, that's the first one. And the second one will come off of the, turn your quadrant snap back on. It'll come off of this one. Looks to me like 1 inch is a little bit short, so we'll go 1.25 at 90. Oops, got away from me. This one will go 1.25 tab 90 enter. Okay, we just want it to be longer than the addendum circle, really, both of these. So I'm using a 1-inch string here, longer than the addendum circle, and a 1.25-inch string longer than the addendum circle, and one more string coming off of this base circle. And here I don't have an addendum circle, so I think one ought to be plenty long. Actually, 3/4. Yeah, let's go 1. I'll go 1. 1. I'd rather be too long than too short and have to redo it, because Lord knows I've done this lab plenty of times. All right. So, okay, so look, I've got a 1.0876 radius for this guy, and a 1-inch string. So get into the Excel spreadsheet and put in that radius. Oops, dropped it. Copy and paste failure there. So I need a 1.0876 radius. Stick it in. Control V, stick it in that guy, and then I'm using a 1-inch string, right? Then all my numbers update. Okay, then refer to these numbers here. Oh, so I got to array the string, right? So array polar. So I'm assuming that you've done the lab previous to this, where I go into detail about the involute curves and how to draw them. We're just drawing more involute curves with different diameter base circles and different length strings. Okay, but if you haven't watched the previous video, then go do that. So we need 20 of these guys at 5 degrees. And the 5 degrees is just how the Excel spreadsheet is laid out. I just chose 5 degrees arbitrary for the string. Okay, it has nothing to do with the number of teeth or anything like that. Okay, now you need to explode. You need to explode this. Whoa! You can exit. Dang, that's dangerous. I almost typed exit. That's pretty silly, but that is a choice on this. Okay. All right. Now we'll just start lengthening, or rather, shortening these things. 0.905. All right. Tedious, but oh so fun. If you like tedium, 0.7152. It takes a while, but it's fun. Then 0.62, 2, 3 decimals, something like that. In what precision is required? Well, when this thing gets manufactured, they're not going to be able to hold the precisions that you have here. I mean, maybe they will, but that's one of the factors, is can they hold the precision that you're doing? And also, when this thing wears in, gear sets wear together and pretty quickly. So different factors that have to do with manufacturing. What did I just do? 0.24, I think. I don't know. I can't remember. I think, let's check. That guy, 0.24. This guy, yeah, okay. Then we gotta pick all of these guys. All right, then, so you don't mess up, just turn off all your other snaps, so that you just have endpoint snap and then just draw your line. You know. So now I got to turn off grid point snap because grid point is fighting me. All right. So I just want endpoint snap. This last little bit looks a little funny, but I don't feel like messing with it. So I'm gonna, you know what, I'm gonna go ahead and use it, although it looks a little odd, but I'm just gonna go with it. I don't know, something's not quite right there. What is this? 1.14. Oh, it's 0.145. You know, that's enough of a rounding error that it's messing it up. So let's go ahead and let's fix it. So it's 0.1458. Yeah, that's okay. You know what? This one here I should probably fix too. 2407. 24. Let's do 241. Okay. So I can move these. If your timing's right, you can just click the point and use the snaps. Just click it and then use your snaps. Okay, endpoint. Okay, shift, right click, perpendicular override. There you go. There's an involute curve. Okay, then let's go ahead and do the other involute curves while I'm at it. So that guy, array polar about this center, 20 copies at 5 degrees, enter, click it, explode, be careful not to exit, check your degrees, there's 95, that's good, there's 100 on the properties window. Everything looks good. Then we'll array polar this one. About the center of this, we want 20 copies at 5 degrees. Accept that with enter, explode it. Check the angle, 95. Just double check your work as you go along on this, because if you make a mistake and you build a bunch of stuff on top of it, you're not going to be happy. You're going to have to undo all of your work. It only takes a second to check it. What's that phrase? Measure once, cut twice? No, it's the other way around. It's measure twice, cut once. That's kind of like this. Is that it? Yeah. So this pitch radius is 1.6314. I'm going to copy that, and the string length is 1.25. So we'll go back to our spreadsheet, and I'm going to paste that radius in there, and then update the string length to 1.25. Then do it again. So this is a really good lab to just learn about gears at a kind of a low level, and also to learn AutoCAD. You know, there are design tools that will draw a gear for you real quick, but you know, you're not going to learn anything by using those things. Of course, if you were in a production environment and you were just doing gears all day, well, yeah, that's what you'd use. But we're not really trying to learn that. We're trying to learn just fundamental theory that you can use to design anything with. 0.965. Right. That's what engineering is about. It's not really about doing the same thing over and over again. It's about doing new stuff. And well, I don't want to wander too much. Well, I do want to wander, but I shouldn't. 0.681. Keep that in mind when you're looking for a career. Decide what it is you enjoy doing. Do you know, and it's different for different people, but you know, of course, but choose a company, if you have the choice, that matches your disposition. If you have a choice, Choice is nice to have. Okay, good enough. Let's get rid of these other strings that are poking out. And you can sort of tell if you've done the thing right, if it just sort of has a, it looks like a string being wound around there, right? Which has a certain shape. I mean, does it look like an involute? And this one does look like an involute. Same process as before on that. Okay, one more. I got this base circle, which has a radius of 0.9063, and I'm using a 1-inch string on that guy. So go to Excel, change your radius to the new radius of your base circle, and I think it was a 1-inch string. I have a short-term memory. Let's double check. 1-inch string, yeah. Then, okay, then same old thing. Lengthen, tab, 0.921. Lengthen, tab. After this lab, you will be really good with the lengthen command. You can put that on your resume. It's funny because it's true. Some of I'm kind of not so happy about. Well, yeah. What's an important skill and what's not an important skill is what I'm thinking about, but I'll keep my mouth shut. What am I doing? 0.50, 525, 52 something? Nope, I lost track. See, I wasn't paying attention to myself. 446, so this one's 367. Ugh. .288. I say at least one more. What do you say? What do you think? 0.209. Say go all the way down. Dang it. You know, that's good enough. Let's stop there. We got extra string. Could recycle that. Use it for different gears. It's just bits. Shift, right click, perp, snap. There we go. Okay, involute curves. Okay, now the fun part, we got to rotate these guys around to their down to the bottom here. Okay, so you select the involute curve, RO for rotate. There's the center point. Then to specify the angle, you click reference, and then you're going to click 3 points. There's the center, and then you want to start and an end point on the angle. We need intersection snap. So the start of the angle is the intersection of the involute curve with the pitch circle. It's right there. And the end is this intersection down in here, where the two strings, where the string line meets the pitch diameter. There it is. Okay, I'll do that again on this one. Okay, RO rotate. The center point is this thing. The angle is reference, center, intersection. I could put it here, but you know what? I'm going to use, I just need a point that specifies the angle, and I want it to go straight down. So I'm going to pick this point here. Okay, and it actually puts it down here. it's on the center line here. It's going straight down. Okay, because I want it out of the way, because otherwise there's just too much going on in here. Okay, and then likewise this one, I want to rotate it about the center of this, and I want okay, the angle is it's asking me rotate, it's saying down here rotate, specify rotation angle, or you could use a reference. So I click reference, and then reference wants 3 points, center point. I messed it up talking about it. I'm just going over that in detail because students always have trouble with that one. So here, I want to rotate this thing, RO rotate. It says specify base point. There's my base point. Then it says specify angle. I say reference. And then an angle needs 3 points, right? So there's a center point, intersection point, right? So that's that thing. All right, now we need to mirror these teeth. Okay, and if you look in the instructions, there's 3 angles given to mirror these teeth about. It depends on the gear that they're on and how many teeth they have. Okay, so look at the instructions. And the instructions for the 24 tooth gear, this one that I've got selected, it's 3.75 degrees. So draw a line here at, I want 3.75 degrees inside this little, right here, and the angle I'm kind of wiggling over. I want that to be 3.75. So I have to enter 93.75. Okay? That doesn't look right. I'm going to do it again because I don't trust it. So line from here, I want down at 93.75 should be about, so, oh, I did that on the length, so I messed, that's why I didn't trust it. So tab length over then 93.75. That looks better. Okay, now use that as a mirror line. So grab your involute curve, MI mirror, and then pick 2 points on that line you just drew. There's one, there's another. Okay, that's it. Then you could use the trim command, select all of those guys and cut off that and cut off that. Didn't work. Do I have 2 of those? Let me delete it. Nope. Control Z. Trim. Must have missed it. That one. All right. Then delete all these extra things poking out. Okay, that's one tooth. Down in here, the mating gear is this guy, the 36 tooth gear. So draw a line according to the instructions. The instructions which I wrote say to mirror this tooth about a 2.5 degree line. So the angle should be 92.5. And why is it 2.5? It's because it's a 36 tooth gear. So that means the spacing from gear to gear would be 10 degrees. Okay, so there's, and then you alternate with the mating gear, right? The mating tooth, the tooth from the mating gear. So that comes down to 5 degrees per tooth, right? And then half of 5 degrees is 2.5 degrees. That's the calculation. Okay, so we mirror this guy, MI mirror, about 2 points on that line that we just drew. I'll use the endpoints. Okay, that's that guy. I can get in here, and I'm going to use fillet radius 0 right there. Trim those guys off, and then spin this guy around 180 degrees. Just select everything and type mirror, and then just type in 180, and then it wants I must have missed the center point. Let me start over. Pick all these guys, mirror, yeah, then center point, then 180. All right, follow the prompts. And what happened? Okay, one more time. Control Z, because I don't know what's going on here. Oh, I think I typed mirror, right? I meant to do rotate. Rotate Yeah, rotate about this center point 180 degrees. It puts it up here. Okay, there we are. That's it. Let's go ahead and you can hold down Shift to unselect things. I'm gonna go ahead and finish up this gear just because it looks, you know, so pretty when it's all done. Okay, then it's array polar here, and this is the 24 tooth gear. Boom. So that's a nice check that you did it right, because it looks like these other teeth are going to mesh properly. And let's go ahead and array those and make sure that they mesh properly. All right, then array polar about this is the center point down here, and this is the 24 tooth gear, and they don't mesh properly. I think that was it must have been the 36. Yeah, that was the 36. I messed up. So I gotta pick all of these guys again. I wish there was a way to pick previous in this program, like there is in other programs that are better. No, better right now. Okay, then array polar center point. This is the 36 tooth gear. Yeah, and before I accept that, look, it's too long. See how it pokes into the base circle? It's too long. So I'm gonna Control Z one more time, undo that. I'm gonna get in here and I'm gonna draw a line across this to this. All right. Then I'm gonna delete this circle because it's in the way, and then I'm going to fill it with a radius of zero. Fill it with a radius of 0. That, and then enter to repeat that, and that, and that. All right. Now it clears the base circle. All right. Now I'm going to go ahead and mirror this guy for the 3rd time. Hopefully it'll be right this time. Okay, that stuff. I want to array polar. There's the center point. There's 36 of these. I'm going to zoom in and look at it before I accept it. Yeah, it looks good. Hit enter. Okay, these clear. Look, there's this tooth. It's clearing that tooth just barely. They're just barely meshing in here on the line of contact. Everything looks nice. Beautiful. Okay, then if you really want to make it look geary, you could delete this base circle at this point and draw a line from end to end, and then do an array polar on that guy. Center point. This is the 24. Okay. Then likewise you could delete the base circle on this guy and draw a line across those guys, and then take this guy and do an array polar on that. And the center point is here, and this is the 36 tooth guy. Okay, looking super geary now. Okay, now, oh, I forgot this gear, or this tooth. That guy? Don't forget that guy. Oh, what's this line? That's the mirror line for this tooth down here. I don't want that. And I'm gonna go ahead and delete that because I don't want to screw this up. So now, according to the instructions, the mirror line for the 18 tooth gear is going to be 5 degrees. So so that's 95 to get it entered into CAD. Or 265, it shows up as a double check. Then we can select that involute curve, mirror, 2 points on the mirror line. All right, and we can trim this up, select everything in there, and then enter, and then click stuff you want to get rid of, escape. Okay, there's my bottom tooth, and I just made it pointy because this one's the one that's going to intersect with the ring gear. Okay, now that's the fun part, right? If you didn't think this was fun so far, now we're going to do the fun part. So this thing is going to intersect with the ring gear. So I need to copy some stuff. I need this, I need this, I need this, and I need that. And I'm going to copy these guys. Now I'm going to use F9 grid snap and F8 ortho to just pick a point so I can drag him straight over horizontally, dropping. Okay, and I got lucky. It looks like the center line is on the major grid point, which is good. Not absolutely necessary, but it's nice. Okay, I need to make this guy point straight down first. So I need to do a rotate command about, so I'm going to turn off grid snap now that I've got this guy moved, about this endpoint. I think it's 2.5 degrees, right? If I turn off F8, it's going to be 2.5. Or is it 5? You know what? It might be, I think it's some odd angle because it's intersecting with the line of contact and all that. So here, do this. Use a reference. So rotate about this endpoint, and then for the angle, click reference. Okay, then to specify the angle, you need 3 points. Center point, and use this tip point. Okay, see how we've grabbed it by the tip, like that. And if we press F8 to turn ortho on, boom, ortho pulls things straight vertical. So now we can just click. All right, so it's pointing straight down now. Okay, now we're going to do this magic where we take this guy and rotate him counterclockwise at 1 degree increments. And then we're going to take this guy and rotate him clockwise at 4 degree increments, because there's a 4:1 ratio between these two gears because they have 18 and 72 teeth. That's 4:1. All right, so we're going to take this guy and do an array polar. Okay, before I do that, it's good to block these things. So these are just separate lines. It's going to get messy, so we'll select all of this stuff, type block, give it a name, tooth, the tooth. It's another Dune reference, the tooth. Then where it says base point, specify on screen, make sure that's checked, say okay. And then it's asking for a base point down here at the bottom. It's saying specify insertion base point. I'm going to pick this end point, the center of the circle. Okay, now when you click this, it's one block, right? That'll save you some grief. Okay, so now we can do an array polar about this point. I want 6 copies at 1 degree. No. Cancel. Control Z. Sorry. I want to array polar about this point up here, the big circle. I want 6 copies at 1 degree. That. So what I've simulated there is the big circle rotating counterclockwise. And I've drawn that at 1 degree increments. But while that's happening, okay, these two gears are meshed. So while the big gear is turning counterclockwise at 1 degree increments, the little gear is turning clockwise at 4 degree increments. So we need to rotate the teeth backwards. Okay, so I made an error. I can still fix it. I forgot to array polar this thing. So array polar, center point, 6 items at 1 degree, that. Because I need the centers of this circle as the big circle turns. I need these new centers. And I don't want to use circles because it's too hard to find them. So anyway, now do this. So explode that. Do this. Take this guy, rotate about this endpoint, turn off ortho, -4. All right, then this guy, rotate about the next center point, which is marked with an endpoint, but it represents the center point of the circle. That guy, -8, it's cumulative. Okay, then this guy, rotate about the next center point, -12. And then this guy, rotate about the next center point, -16. And then this guy, rotate about the next center point, -20. So what we've done is we've sort of drawn this tooth kind of pulling out of the groove as the two gears do their thing, right? So we'll take this and we'll mirror all of these guys about the center line. Mirror those. Okay, and we've got the full tooth really, so I'll outline it in red with heavy. And so we're just going to draw lines. Start here and just pick like, a few. About that many. And then pick all of those guys and mirror them. I'm going to use the grid. Turn the grid on just for a second so I can snap 2 points for the mirror line. Okay, then pick these guys on. Pick these guys. That's your tooth. And do an array polar about big circle. This is the 72 tooth gear. There it is. And then get in here and draw a line there and array polar that about center. Once again, 72. There. Nice. All right. And it's a little shy. It's a little shy of the base circle, which is good. So everything's cool. Okay. The other thing I asked you to do was blow this up, just so that I could see it when you email it to me. So copy this just somewhere, pick a point somewhere to put it. You could put it here. Then grab it again, the copy, and SC is scale. And then the scale command wants a point, and then drag. And another point, and then you could grab the whole thing one more time, and M for move, point, point. You could put it in the middle. Yeah. Okay, maybe rectangle now. Okay, capture that and turn it in. Capture the screen, turn that in, that's it. Okay, hope this was useful to you. I hope you have fun doing this. I always do. And we'll see you next time. Bye-bye.